In this video, I'm going to walk you through lesson 1 of the unit 8.1 by OpenSciEd. This entire unit is about contact forces. And the driving question is, why do things sometimes get damaged when they hit each other? Now, I'm going to go through a slideshow, and you can open this slideshow by clicking that link right below in the window and just follow along as I go through the slides. And I'm going to open up some links to share some resources that can be found in lesson 1. Before we jump into lesson 1, I want to share with you the first couple slides of the slideshow. Slide number 2 provides kind of an overview of the 3 lesson sets. So we've got the first lesson set that's talking about what happens when things make contact in a collision. The second lesson set is more about energy and how the contact forces relate to the energy and how the variables relate to the energy, like mass and speed. And then the lesson set 3 is an engineering lesson set. And so we're going to take those science ideas and also learn a little bit about materials and the structure and function of materials to create something to protect a device like a cell phone. Now, you will see over here, these are the big summative assessment opportunities in the unit. Lesson 6, which is the end of the first lesson set, has a summative mid-unit transfer task. This one is on soccer. Let me spell that correctly. The second one is lesson 10, end of the second lesson set. This one is actually on baseball. So now we're going to add more ideas about energy into that transfer task. Lesson 14 is going to stop right here. And this is actually considered a summative assessment. Their designed solution is considered a summative assessment. And then in 15, we do a transfer task, but it's all engineering ideas. And can they apply those engineering ideas into a different scenario, which is the cheerleading headgear transfer task? Now, if you look over here, these driving question board categories, I provide these because teachers are often very worried and nervous that the questions that students ask will not fit into a category that is going to be investigated in the unit. And I will tell you, when I first started doing this, I was always worried about that when I was doing professional learning events, that teachers were going to ask questions that did not relate to the different lesson sets, and every single time they related. And so it really put me at ease the more I've done it, and you will find this too, that the questions will relate because that's how these units were developed. Now, if your students ask questions that do not relate to the unit, it is perfectly fine. Just create a category called Other. Now, the reason I have these for you, and you don't have to have all of these on your driving question board, and I'm going to show you 2 examples as we go through lesson 1, but the way I do driving question boards, especially if you're new, because driving question boards can seem overwhelming and a little bit hard to manage. The way I do it is I say, who would like to share their first question? And I get the first question shared, and let's say it's about let's talk about motion, the direction it was traveling, or motion, or something like that. So I'll say, okay, does anybody else have a question about the direction the car was traveling or the motion of the car? And then I'll have them read their question, and I'll collect the sticky notes from all the students that have something related to motion. And then I, as the teacher, suggest the category. Well, it sounds like these all have to do with motion. And so I write the category on top of all the sticky notes that I put on the driving question board. So 2 things here. I'm placing the sticky notes on the driving question board. I know some people prefer to have their students place them on the driving question board, but I find that some students cannot handle that type of chaos. If you have an incredibly well-behaved class, more power to you. Let them go to the board. It just gets a little distracting when someone's on the board and someone's trying to read their next question, but figure out what works for you. The point is, once everybody's asked their questions about motion, and I asked, does anybody else have a question related to this? And if they don't, okay, let's go to a new question. And who would like to start off our next category? And someone asked a question about, let's say, how to protect cell phones. And so that would be this category down here. I know that's going to be the 3rd lesson set. I'm not going to tell them that, but I know that I really want that category on the board. When it's time to navigate, I can say, well, we still haven't had questions about protection. Let's go there next. Anyways, so someone has a question about a cell phone case, and I say, great. Does anyone else have a question about cases that protect cell phones or protect other devices? I have them read their question, I collect their sticky notes, I place them all on the driving question board, and I label it protection. So the point is that I'm really controlling this driving question board process. There's definitely a more student-driven way to do it, but as a beginner, that is a nice way to start. So let's jump into our first lesson of lesson set 1, which is going to answer the question, how do objects interact when they make contact in a collision? Lesson 1 is always the anchoring phenomenon routine. No matter what unit you're in, you're going to go through those 4 elements of the anchoring phenomenon routine. The first thing we do is we explore, and in this case, we're going to explore with providing some statistics. And you can see, you'll read through these statistics talking about how many people break or crack or damage their smartphone screens every second or every year. So large numbers here. And then you'll go back to students and you'll talk about what experiences do you have with cell phones breaking? And so we're making it really relevant to their own experiences. We're actually going to model this with some CD cases. So if you get a kit, there's those clear plastic CD cases. Kids often don't know what they are, but you are going to kind of demo, well, how did you drop your cell phone so that it had damage or you cracked it? And then they come up and they act it out. Kids actually really like to do this, sometimes a little too much. So control the madness. So anyways, we demo the model some of the ways we've broken our cell phones, and then we introduce the 3 types of collisions. Now, the 3 types of collisions, there's guidance in the teacher guide about how to develop this. What I do is, you see, these are little pieces of paper. And so I have these pre-made and off to the side. So you'll see in the teacher prep when we go over it, you're just going to have the title and the ABC. And then they're going to talk about the different types of collisions. And you're going to kind of guide them to thinking about, well, which object was moving? So this white one is representing the cell phone. If the cell phone was moving because you dropped it, and it fell on the ground, here's my little motion symbols, then the ground was actually standing still and the cell phone was moving. This is a very common collision scenario, and we're going to label this A, and we're going to take that piece of paper I have pre-made and I'm going to slap it on the A. If someone then says, well, actually, I was running with my cell phone and my friend was running with their cell phone and they hit each other, so they were both moving. So I get my C little piece of paper and I slap it on for C. And then we say, does anyone have an instance, a different type of instance? And if they don't come up with it, say where your cell phone wasn't moving, but something that was moving hit it and damaged it. I've heard people sat on their cell phones or things like that. So then you get the B up on this category list as well. So we've now categorized frames of reference to consider who was moving, the cell phone or the other object, as far as when damage happened. Then we brainstorm related phenomenon on index cards. Green index cards, or any color you choose, would be no damage in a collision. Red can be considered damage. So if your cell phone broke, that's an example that would go on a red card. If a basketball hit the desk, basketball and the desk didn't get hurt, that's going to be no damage. So they're going to think about related phenomenon of collisions, and we've actually already developed the term collision and earned that word. And then we are going to share, let me show you what the brainstorm looks like. This is the slide that supports that. So if you don't use red and green, you're going to need to change these colors here on the slideshow. But they're going to brainstorm individually on their index cards. And then we're going to think about the similarities and differences between all of our examples. Now, in the teacher guide, it will talk about have one corner of your room be scenario A, or that type of frame of reference A. This corner of the room be B, that corner of the room be C. Now, if you have your green card has a scenario that falls in A, go here, B, go there, C, go there. So you're getting like frames of reference together. And so when they get there, they find a partner with someone with a similar frame of reference, whether it be group A, B, or C, and they talk about similarities and differences. We're getting them to start thinking about like the variables. that contributed to the damage or no damage. And then we do that again with the no damage. Go to the area of the room, A, B, or C, share with a partner. Think about your similarities and differences or variables that contributed to no damage. And then we bring them back together. They go to their desks, and we're going to set up a T-chart in their notebooks. And in this T-chart, they're going to think about patterns in collisions. They just talked to two partners. What kind of patterns were shared? What kind of factors and variables were shared that might cause damage in a collision? So these are initial ideas, and they're brainstorming them in their notebook. Okay, so then we're going to go back to our related phenomenon on our red and our green cards, and we're going to categorize them. And so we actually get those cards and we create kind of a bar graph, a horizontal bar graph with our cards. This is what it looks like. Notice that we've got the A, B, and C lined up. That's really why I like the A, B, and C to be in this order. And then if you have a really large class, you'll need 2 extra chart papers. And then you're going to have everyone bring up the A for no damage. Everyone bring no damage. The B for no damage. The C for no damage. Now let's do the damage. And so you'll see that A is the most common type of frame of reference where the thing that got damaged was moving, and it usually falls on the ground. And so you're going to see which scenario happens the most or the least. And then we're going to consider how we can explain this damage or no damage. Why are we seeing these different examples and related phenomenon? So we hand out this initial model handout, and you will notice that there's 2 time points. So the model is scaffolded by time. So first of all, they're going to pick any collision that they heard of or that they wrote down. And they're going to explain, is it from scenario A, B, or C? And was there damage was there damage in the collision? Yes or no. So here's time point 1. What would you see the materials what were they doing if you could stop time the moment they touch? The moment they first touch. This is pretty simple. Obviously, you're going to put the 2 objects side by side. Time point 2, and this is where they're going to have some questions. What would you see the materials? What would you see the materials they were made of doing? It's kind of a hard one. If you could stop time a split second later. So we want them to start thinking about the materials that it's made of. You can see that that's why that's prompted there. And so what would the materials be doing a split second later? So if they cracked, if they bent, if they didn't do anything, we want them to think about what's happening at that split second after contact. So after they complete their initial models and they compare them with a partner, they look for similarities and differences. We get together in a scientist circle and we make our initial consensus model. So there is a chart that you will need to prep for this. We'll talk about it in the next video. Basically, you're going to have the top row and the first column filled out, and we're going to ask students to share their ideas about what did you put at time point 1 for the damage column. And basically the damage and no damage, they're going to be the same. They're touching. You're going to talk about the changes we can see, and these are color coded in pink. For damage, bending, popping, breaking, shattering. If students are not sure about something, or if there's uncertainty or some people disagree, I often say, is there anybody who is not sure about this? Does anybody disagree? And if they do, I put a question mark. The idea of a consensus model is to find areas of agreement and disagreement. So these question marks are really important to show that we're not sure or we disagree. This also is going to lend itself to creating questions for the driving question board. So then we talk about what are some interactions we cannot see, and we color coded these and put them in blue. Maybe there was some energy transfer. Maybe there was a force we couldn't see. And then we talk about what happened a split second later. Oh, well, it broke, it bent, it cracked. But we're not sure about some of those things. Permanent damage we can see. We're generally more certain about that. But the no damage, we're not sure. We're not sure what's happening to those materials. And that is really important. We're going to go into answering that in the first lesson set. Okay, then we go back and we revisit our T-charts in our notebooks. that we wrote about patterns and factors or variables that might affect damage in a collision. And we make a class chart. I made mine a little different than the teacher guide. Mine looks like the T-chart that are in their notebooks. I had them share ideas. I think that the teacher guide kind of just wants the variables and factors, but not a big deal. And then we ask questions and develop a driving question board. Usually this can be a little difficult if you have a really big class, because you're going to end up with 100 sticky notes on here, and who has time for that? So let me give you a little bit of a trick. I often put students into groups and I have them share their questions. Actually, first I have them write questions down in the notebook. Then I have them share with their group, and the group decides on their top 3 questions. So you're only having each group put 3 questions on here. It's much more manageable. I will go back and show you the sample from a professional learning event that I did. Here are some of the categories that came up. Factors and variables. We just use this terminology. That's why it showed up. Speed is actually a factor or variable, but there were several. So I made speed a category of its own. Angle and force, materials and protection. There's your engineering right there. Damage and no damage. Often what you talk about prior to the driving question board appears on the driving question board. I just want to go back and look at the categories real quick. We've got damage, factors and variables, force and energy, braking, not braking, and timing, which I didn't have in my example, but that can come up because we talked about time point 1 and time point 2. Okay. If you don't have a category that you want on there, do not worry about it. You can add it at any time in the unit. If nobody talked about damage or protecting a cell phone, but you want that on there, if it comes up at any point in your lesson, say, hey, that's an interesting question. Can we document that and put that on the driving question board? So then you get it on there. It can happen at any time. So then we think about, how could we start answering some of these questions? What data could we collect? What investigations could we do? And we brainstorm some investigation ideas. One scaffold for this is you can actually have each student or each small group think about investigations for a category on the driving question board. And that's about it. We think about investigation ideas. There is some guidance about setting up a notebook, but doesn't need to be done right now. You can do that at the start of lesson 2. You also need to think about your notebook setup, because your table of contents, progress trackers, all that is going to be different from teacher to teacher. And I'll talk about that in another video. All right, that's it.